It's going well. It says it's showtime. Dan, how are you?
It is. I am doing pretty good. I guess it is showtime. I don't know if we're gonna put on a show, uh, but we'll do our best. Um, we were right before we came on air. We were talking about our preferences for um, development machines and talking about potentially what machine our special guest would have. I'm curious, do you have any? So I guess for context, right? They weren't there. It turns out. The We were talking about how we don't prefer Mac laptops, um, and I'm curious, do you have any Apple products at all? Do you own any Apple
um,
products?
I have a pair of the white corded headphones that
Mm,
are Apple products, and I had an OG Apple TV one, like the computer that connected to your TV, that I bought broken on eBay and fixed, and then hacked in order to put like uh, Xbox Media Center or whatever. So it was like a network player of stuff. But other than that, I also bought a broken iPod like click wheel and fixed that and put Rockbox on it. So mostly I
oh, that's
have
cool.
Apple products to put Linuxy stuff on them.
Yeah, yeah, for sure. Well, Jason's here, so I think the question we should lead off here
Hey,
before I even introduce y'all is what machine are you on right now, Jason?
I am on a MacBook Pro,
All right.
an ARM M1 MacBook Pro. If it's the only laptop I could reasonably use right now, so if that's what stymies us, if that's what makes this not work, I apologize.
No,
Is
yeah,
that
that
your
should
daily
be
driver?
perfect.
This is my daily driver. Yeah, this is
Nice.
what I use all the time. So I will be familiar with it, but it sounds like perhaps you won't. I don't know. I hope I'm not
Yeah, it'll be
dialing up the
totally fine.
difficulty. Okay,
It's
okay,
Linux
cool.
adjacent, so we'll give you
Yeah,
a
yeah,
pass.
yeah. It's Linux
Yeah.
enough.
So follow-up question. Does anyone at Chainguard use a Linux machine as their daily driver?
Uh, there definitely are
Okay.
folks that use Linux. I would say even among the unwashed Mac masses of us, many of us like connect to a cloud workstation that uses Linux and is actual Linux, not just Linux adjacent.
Right.
So there's plenty of actual Linux involved. Don't worry. But this is the MacBook. This is the MacBook I use to connect to the cloud Linux thing to
Cool.
do actual work.
Well, to dispel any myths here, Goliath supports all the big three OSs. Obviously, Linux, you're going to want to support that. But then
Yeah,
Windows and Mac as well are all going to build for Goliath just fine.
of
Yeah.
course. Good, good.
The more of a formal introduction, I guess. I've known Jason for a while. We've given some conference talks together. We've hacked on some silly things, some questionably useful things. But Jason, I thought it would be great to have you on because we kind of talk about we talk about Goliath just anywhere really about having these kind of like two sides where we're taking a firmware and embedded development and kind of connecting it to the cloud and typical cloud development. And we really want to give a good experience for folks who have expertise on one side of that or on both sides. And so you're our first external guest on our Friday afternoon streams that we do here, and you have a lot of experience and expertise on the cloud side, but less so on the embedded side. But are eager to get into it. So I thought you'd be a great can to have on. And then Mike is my coworker here at Goliath. Mike does lots of many cool things, but primarily firmware and DevRel. So introducing y'all to each other and to the
Good to
audience.
meet you.
Yeah, good to meet you too. Yeah, I would say I would amend what you said. You gave me a little bit too much credit in my familiarity with embedded anything. Like I
Fair
can
enough.
barely spell embedded. I have years and years of cloud, infrastructure, whatever, at many levels, and part of what sort of draws me to this is like there's this whole other universe of programming I've never done. I've never, I don't know some of the words you say on some of your like streams. So
For sure.
I'm excited to learn about this alternate upside down world of tiny little blinky lights and actual physical things, and then to tie it to the cloud stuff that I do know about that I can pretend to know about. Seems super exciting. So yeah, I'm super happy to be here.
Awesome. Well, that sounds great. Well, we usually go for about an hour, or a little more, or a little less, and we can do whatever. But I think we can go ahead and jump into it. I actually want, once we get to the embedded side, I think Mike is probably, or actually certainly the most equipped, probably the most equipped on either side, actually, to kind of provide guidance, that sort of thing. Mike actually does training every month, and this week did a Golioth 101 webinar. So expert instructor here. But I thought we'd just start by getting you a Golioth account, and the kind of like our getting started flow is, based on getting you a device connected to the internet as fast as possible. And so if you want to, you can just share your screen and we can get an account created, and then we'll start doing the interesting stuff.
Yeah, you got it. Let me share screen.
And we can also hide at various parts if you're entering credentials or whatnot.
Oh, that's fine. My password for everything is 12345. So.
Oh, good. Okay, same here.
It's 1 digit more secure than mine.
Ooh.
On which side?
One?
Yeah. 0.
Ooh, you've already signed up. Excellent.
Ooh. I went through the. I did it on a different window, but it went through the Google account thing. I'm clearly that in a team of just me. No offense to you two. Currently, prototyping even feels strong.
Ready for production.
I have devices out in the field. Anyway,
maybe we should add a planning to deploy 0 devices as an option. All simulation.
I am hoping not to start a small fire in my home. That's the level of expertise
right.
I'm going for.
We should add we can, we have the thing where it's like ask for help or whatever, like where you can chat with someone. We should also have like a call fire department, option as well.
All right, let's I'm here. I think I'm in.
All right.
Create a project.
All right.
Create a device.
You got it.
Oh man.
So many options to name things here.
What's a hardware ID? Is there a yeah. I'm already out of my depth.
Yeah, go ahead, Mike.
So hardware ID, a lot of companies like to have some kind of naming scheme for their devices. So it might be like a MAC address or an IMEI number or just some internal serial number. I just pretty much leave that blank until I need it.
Okay. And credentials PSK auto generate is fine.
That's the easiest. Yep.
Perfect. Same defaults.
And you'll be able to access these later as well. So
okay. Perfect.
No worries on that front.
I'm just going to copy these to another thing, just so that I'm sure I will use these later, soon even.
That is one aspect that you may get with Golioth and other platforms is there is no way to connect to Golioth insecurely. So we don't. There's maybe a bit. I'm actually interested to hear what your kind of perception when you hear IoT is, because before I joined Golioth, I was like very skeptical, not like NFT level skeptical, but I was like, there seems like a lot of bad stuff happening in this area. And then I was actually quite motivated by the idea of changing that paradigm a little bit. But what's kind of your like knee-jerk reaction?
Yeah, I think I have some general skepticism toward the security posture of IoT in general. But I can like sort of be nice and try to understand why, right? Like I feel like engineering in general is you barely get it to work. wherever you are, embedded cloud, anything, like you barely get it to work. You get it to work a little bit more reliably. You ship it to production, and you fix bugs forever. Like that's the four stages of everything ever, right? And I'm not unguilty of this. I do this all the time. But it seems like IoT is hard, can be hard. Maybe historically, I'm not sure how Goliath handles it, but like fixing bugs forever seems very hard in the remotely disconnected, like world. In a cloud environment, it's even hard to deploy stuff to the cloud that is, right there. But it's even harder if it's like, who knows if this device is even plugged in? Who knows if this device will ever be plugged in again? Like, who knows if it's within range of anything that can receive a signal? And so I guess I assume that it is in that bad state that I assume it's in, because there is the iteration cycle is harder to be sure of, right? Like you can't push security updates as easily because there's a trillion tiny little devices running everywhere. Simplifying that and making that easy seems super valuable. Like making it easy to push your security updates to everything seems like a real win, like you could, make the world more secure. I will also say maybe folks stop at make it barely work and then skip and go straight to push it to production, and ship these devices out as quickly as you possibly can, and then miss that, make it better step in the middle. So maybe uncharitably, maybe folks are skipping the QA cycle. I would never do that. I would never do that myself.
Never in your life. Yeah.
I would never.
Yeah. I feel like one of the things that was, we have some customers and then, there's lots of other companies who are not our customers, who this is also true of, that, have devices that they expect to be connected for, on the order of a decade or longer without a human. Like we have one customer where a human by definition will never, ever be able to access this device, or else like the entire product would be ruined essentially. So, like in some cases it's like, it's not even hard. It's just like definitionally not possible. So, and another thing that I think, I've developed a lot of empathy, I think, for embedded developers since working at Goliath, because there's just a lot of constraints that we don't have in the cloud. A lot of times we can light more money on fire and accomplish what we want, right, in the cloud. So like, it's not like a question of whether it's possible necessarily.
Mm-hmm.
It's a question of, how much we're willing to spend. And there's hard trade-offs to make. But like sometimes if you have made a large capital investment in devices, for example, and you're out of memory or you're out of ROM or something like that, like what are you gonna trade off, right? There's no getting more. I
have a friend who makes his entire career in optimizing other people's microcontroller code for that very reason. Like, we ran out, it needs to do this thing, make space for us.
Right. The cloud is perfectly happy to, I ran out of memory in my 32 gigabyte machine type. I guess I'll use the 64 gigabyte machine type.
Right.
The cloud is perfectly happy to give you that drop down. And hardware devices are like, no, this is it. You don't understand. This is it.
Right.
There's no, So that's part of what's like interesting and exciting about this to me too, is like, what if I had to live inside of constraints again? What if I didn't have an infinitely scalable, modulo the amount of money you're willing to burn, infinitely scalable cloud to my heart's content? But like, what if I really had to think about, do I need this memory? How could I do this better? So that's part of what's exciting about this to me too. But we'll see whether I come back crying when I say like, no, I miss my 32 gigabyte machines.
Well, if that happens, we'll consider it a failure on our part. So,
Good.
But yeah, let's keep going and see where we can get to here.
Yeah. Should I use this simulator?
If you want to.
Okay. This. Oh, copy device credentials. Are the things that it showed me like secret to the point where folks should not be seeing these?
The PSK, yes. It will
Okay.
be obscured when you paste it in here.
Oh, okay.
The so it's just credentials for this specific device. And basically what they'd be able to do is like send data on behalf of this device. If they were to do that.
Right. This isn't like, this is purely demo stuff.
Yeah, and this is really getting started stuff too. If you go to production, we have X509 certificate authentication that we suggest everyone use.
Yeah, nice. That's another area of this I'm very interested in exploring is like the security, how you make this secure and stuff like that. So I guess I'm hitting send. Is it coming through somewhere?
Yeah, this actually, I think some good feedback for us. If you're not aware of where this data goes necessarily, I think it mentions it in the description on the simulator, but it's certainly not obvious, and we don't jump you to the page.
Light
But
TV stream.
yeah, exactly. So if you go in there, you can see some of those values that you sent.
Yeah, nice. Okay, so that was an issue of me not reading the text directly above the boxes I filled in.
I'd say it wasn't obvious to you to the point where you didn't have to think about it, then it's an issue on our side. So I think we can make that better.
All right, I appreciate it, but yeah. All right, cool. So this data, these credentials are able to send sample data through the Light DV stream.
Exactly. Yep.
Right, cool. How would I go about making a device do things?
Do you have a device?
I do. Let me introduce you to our patient. I bought this at Micro Center. I bought this at Micro Center for $10. There
we go.
It's still in the packaging. I cut a hole to make it go in there.
Ooh.
Very
nice.
Didn't want to lose it. Yeah, very. This is ready for production, right?
What's the title of that board?
It is ESP32 on the back.
Board. W Room 32. Perfect. Yeah, this will work. This is great.
All right.
Dan, cool. I'm inclined to do the Zephyr route on this. Do you have a horse in the race?
I'm always inclined to do the Zephyr route, but maybe we should explain what the options are available.
Yeah. So we support multiple flat platforms. For this board, there are two choices. One of them is Golioth support for ESP IDF, which stands for Internet of Things Development Framework, IDF.
Nice.
And that is based on free RTOS, and it only works for the ESP, the Espressif 32 devices, but it is the like flagship Espressif company maintains that and all that. So like you get the best support there. It's just that I live my life in Zephyr, which is an open source real-time operating system. I also use ESP IDF. I just like 95% of my time is in Zephyr. And if you write code for this board with Zephyr, and then you get another board like a Nordic board or an NXP board or just a myriad of other boards, you can probably reuse the same code on that board because Zephyr has abstractions across the different hardware vendors.
Okay. First of all, IDF, ESP IDF, the I stands for IoT, which is my favorite kind of acronym, is a stacked acronym. But it sounds like if I went with ESP IDF, that I would be constraining myself to Espressif boards specifically, and that Zephyr means that I could use not only other Espressif boards but other non-Espressif Nordic. And okay, I want
honestly
that one
for the stuff we're doing today, like the actual Golioth calls are the same on either system, so like porting it over later will be easy. But if you're going to production with thousands of devices and you don't know if you're sticking with the same hardware, then Zephyr's a good option as well. But if you knew you were going to do all ESP32 devices, then I would go with the ESP IDF. But today, let's go to our docs, don't you think, Dan?
Yeah, that sounds great. Also, another note, just because you're already involved in lots of areas in the Linux Foundation and whatnot, Zephyr is under Linux Foundation, just like Linux, obviously, and Kubernetes and such. So there's some nice like ecosystem benefits. They do a lot of the same practices and things like that across the community. So that's something that I've actually personally found very valuable, such as like when submitting talks and things like that. So
yeah. Cool.
Cool.
All right.
So for today, I suggest the Getting Started tab up at the top.
we go.
There is a device examples on the left sidebar. So we already went through the Golioth web console managing credentials. We already went through that part. We're up to this run example code on your hardware. And we're going to compile our own example code so we can drill down to the C files. Here is a discussion of the different platforms that you can choose from. And I think the very next one is Zephyr with Golioth.
Yeah. Okay.
And we're going to set up a local build environment.
Perfect. Let me open some tabs.
I feel like my hot take, well, actually, I don't think it's a hot take. I think it's a cold take probably, is that if you get past the setting up your development environment when you're doing any sort of embedded work, then you're 95% of the way there. That's like the hardest part. Although I will say, so you're about to see here that Zephyr has this meta tool called West, and it's like an abstraction over lots of different things, but primarily Git and CMake, and also like integrates with like flashing the board and that sort of thing, and a variety of other things. It's a pluggable system. When I first joined Golioth, I was like, this is the worst thing that has ever happened. Like, I am deeply upset right now. And there are still things that kind of upset me, but the more you use it, I don't know if it's Stockholm syndrome or I think it's actually legitimately well thought out. But I will say that other ecosystems, you do not have West, and it's more like, all right, let's go find our compiler, and it's pretty tough. So you learn to love West.
ESP-IDF has IDF.py, which is basically the same thing. It's like wrapping all of the stuff that they use. So I don't think it's a bad approach. I like these because we're not locked to an IDE. Like you can totally use an IDE if you want, but I prefer to like Dan and I are on two separate planes of abstraction. I don't want the IDE abstraction, and Dan's like a whole level lower where he's like, I don't even want the command line abstraction.
There's that XKCD that's like, oh, real programmers like, you know, wait for radiation to bit flip things for them.
Right. I
don't use a keyboard. I just stare at it until the bits flip the direction I want.
Right. I will say where we are aligned is Mike and I are both pretty diehard NeoVim users. And so that's where our workflows align. And Mike has done some pretty awesome config tips that he shared with me as well.
Nice. I will. I'm a Vim user as much as I can, or VS Code person. So maybe I'll pretend to be more Vim person for this crowd.
Yeah, I spend a lot of time in. Julian just said it's 95% config flags for Zephyr, and I spend a lot of time in menu config trying to find what's not letting me build my thing.
That's a good example, though, Mike. I never in my life have opened menu config. But the way that I do it is I build, and then I go into the build directory and I look at the kconfig output, which has every single flag that's available, and then I just grep in there to see what I can find, which is objectively a worse workflow. I understand, but I don't know. Menu config scares me. I feel like it's like I don't know why there's a UI happening, you know.
That's not even the fancy UI. There's also a GUI config. Have you tried that one?
No, I haven't.
Yeah, it'll pop up a Windows system with buttons and everything.
Oh,
same interface otherwise, yeah.
Buttons. Wow. Who needs those?
Buttons. Oof. All right, so I'm just copying the commands from the getting started. I'm at install Golioth firmware SDK, which is this. Is that right? Does that look None of that looks scary.
I think it looks right. Let's see. It's going to go into your home Golioth Zephyr workspace directory. We're going to CD into that directory. Yep, I think all that looks right to me.
Okay, cool.
This will take the rest of the podcast to finish.
This is actually my number one qualm with West is that, and this is I want to be clear. This is in my own issue. There's a reason why this is the case, but by default, it kind of just grabs the kitchen sink. Of like
not kind of like it does. Everything that's in the Zephyr universe is currently getting downloaded.
Yeah.
Awesome.
And there's a very good reason for that in that no matter how you're getting started, it is highly likely that it's going to work, which is good, right? Because you have everything, so it's bound to work. You're bound to not have an issue with you didn't, install the dependency, which is, questionably useful if you're installing all dependencies, but so that's my number one qualm. But I frequently will go in and do some modifications to make it not download everything. But
yeah, likewise. Although it is more, I wouldn't say like a power user, but it's a mature user feature because I was just doing some changes to our training firmware and I'm like, why is it this building? And I'm like, oh, I have an allow list and the library that I need is not in the allow list. So when I'm doing the checkout, it's not getting that. And it took me like probably 5 minutes to figure that out. And I wrote the allow list originally. So blame me.
When you say, just so that I get a sense of scale, when you say downloading the whole universe of stuff, is that gigabytes? I mean, hundreds of gigabytes. What is?
Yeah, I would say it's probably
three
3 gigabytes of open source repositories that are being put into a tree. There's a Zephyr tree, and then there's like a modules tree that has all the extra stuff in it.
Okay. I hope I have enough disk space. I'm always running out of disk space because of Docker. Let it be known.
Right. Yeah, that's it. When Mike said 3 gigabytes, I knew internally though in your head you were like, oh, so it's nothing.
Yeah.
No, it's a lot, but I regularly do Docker system prune on my workstation, and it's like freed up 200 gigabytes of garbage.
Right.
Why did you do that to me? Why would you write that?
I just reinstalled my.
Oh, sorry. Go ahead, Mike.
I just reinstalled my Linux system, and when I made the swap drive, I was like, "How much swap do I need?" I ended up making it 32 gigabytes because I had it, and I'm like, I have browsers that just eat and eat and eat, and I need more. So,
yeah.
I also just dropped a link in the chat here that has the link to the Zephyr West manifest, which you can see if you're interested in what's coming in here.
You might want to just pull that up while we were waiting, because I'd say we've got a good 10 minutes before we're going to be building anything.
Depends on how powerful your machine is. Yeah, I can pop that up. Or wait, Jason's already got it.
I got it. Yeah, I mean, or
why does it take so long for this to run? Is it because it's so many chunks for each repository, like so many hashes?
I don't know. Is the default command to do the shallow checkouts? Yeah. Okay. That's
no. We did the full Monty. Yeah.
Mm. Yeah. A shallow get cloned by default would be nice. Yeah. I agree. But you can. There are some flags you can pass to change the behavior here. But I'm assuming that it's like similar philosophy of like if you need to change versions, you have them all locally. But anyway.
Yeah. So the Zephyr, this West config is what repos to check out, basically. Like these are.
Yep.
Basically has the repository, the path where you want to put it, and then the hash or branch or tag that you want to check out. And then they're also recursive. So when you checked out the Golioth repository, it just pointed to this repository and said import true. And so then it'll just pull everything here. But you can do is put in allow list, and then you just pick out the libraries in here that you want to allow, and the rest will be ignored from the recursion.
Okay, so this is like all of the things to be able to talk to all of these different devices I guess this one is possibly one I do need, but
Yeah.
if I switch to an Infineon device, I could use this. I'd already have it. Nice. Okay. Cool. It resonates with me that you said, Dan, that getting set up is 90% of the work.
Right.
Before joining this stream, I tried to do some of that myself, and I think I chose the harder path than this. Rather than use Golioth and getting started, I tried to like read embedded Rust pages and installed Rust tool chains that with increasingly long and archaic names, and none of it worked, as you may be surprised to find out. So, yeah, I'm happy to be doing it on easier mode.
I will say that I think that with the embedded Rust that I've done, I do think that once you get everything you need, it feels like a better experience because you're in that kind of like, I mean, obviously Rust is, I don't know if you consider it a high level language, but like you're in that kind of like high level package manager kind of experience at that point. And so like, you know, Zephyr, for example, is kind of constrained by the existing capabilities of C package management, which is pretty minimal. And so it's going to have to do everything basically via just like Git cloning things. So I think once you get set up with embedded Rust, it can be a really good experience, but it's very difficult to know whether it's possible to use Rust on what you have. I mean, it's probably possible in some sense, right? But to do anything meaningful with it, and that initial getting set up does feel real hard to me.
Yeah, and I kept finding tutorials and videos that were like from it's already set up. Here is how to do, here's how to make a light blink. And I'm like, well, that seems very simple. That seems very easy. But like behind the curtain was 6 hours of installing just the right toolchain stuff. And I hadn't done that yet. So
right. Yeah, and I don't think it's unique to any particular ecosystem. Like just for embedded, the tool chain is always the worst part of it.
Yeah, it's not. Yeah, from my cloud experience, it's also like me with all the tools already installed and awareness of what I'm doing can get a lot done on day one. But then a new person joins the team and it's like, oh, you didn't install these 18 tools I forgot to tell you needed. You didn't install. Is everything up to date? Is everything working? So yeah, it's not a slight on embedded Rust ecosystem or embedded ecosystem. Everything is sort of built on a pile of pre-installed tools and pre-known knowledge.
Yeah, I will say I think the maybe like obviously the modules that we're installing here and everything are great. And Wes managing that is really nice. But I think the part that really makes the experience better is this SDK-NG I just posted in the chat here. Basically just ensures that you have all the different compilers that you need and any development tooling and that sort of thing. And it will just kind of, we'll install things in just a moment, but it does that sort of what feels magically.
We should go to the releases and read a little bit because there's a minimal install that I haven't used before. And if we can figure out how to do that, that will be better.
Is the minimal install like more minimal than just choosing a single platform?
No, that's what it is. It's
Okay.
I always install everything. So have you done the choosing a single platform before, Dan?
I have.
Okay.
And I can't remember. I feel like it prompted me, but I can't remember for sure.
Look at all these choices.
Where do I get this SDK bundle?
We'll tell you how to do it in the getting started as well.
Oh, it's hold on, let me
it's strange that those aren't rendering. I think that's broken in the release. Because they should render links there that take you to the download.
All right. I'm here. Something has happened.
Yay.
All right.
And now back to install. That was install Golioth firmware SDK. installing Zephyr SDK toolchain is this guy. All right, 3.5 minutes.
Does anyone want to perform anything? Fill the time. Mike's a musician, so
Dramatic reading from something.
yeah, right.
Resolving github.com 140821113.
Oh man, you could do a whole YouTube series of dramatic readings of terminal outputs.
In addition to having a MacBook, I also have AirPods, and I have it configured to read text to me, when I get a Slack message or when I get a whatever. But I also have Slack notify me when GitHub events happen. And so it's like, I'll be washing the dishes and I'll hear like incoming Slack message from GitHub bot. And then it just like reads the commit message and the commit SHA. And I'm like, just quiet, shut up. I don't need you to read 40 random hex characters to me. Please stop.
Right.
So I'll pipe this to Say. Do you guys know about Say?
No, tell us.
No, I don't know. Yeah.
I don't know
Whisper
if you'll be able.
is whisper like the tone of voice?
Yeah, there's a what is it? I'm not sure you'll be able to hear it because on headphones, but Say is the Mac read this text to speech thing.
Oh, cool.
And so sometimes in my if I'm running a long script, I'll build the thing and then say it's done, or it finally finished or something.
Oh, that's awesome.
I did that recently. We're cycle testing some firmware, and so I wanted it to keep testing until it broke and then play a bell sound. And there's a Linux or Unix special character for bell sound, but I cannot get it to work. So I ended up just using a similar program.
Oh, I read a blog post about this recently. Oh yeah, it's from let me see.
Grandma English UK.
Anyway,
oh man, I gotta see if this is available outside of Mac OS.
This is a great blog post if anyone is interested in terminal bells.
Oh, I am. I'm gonna eat this up. Oh, where'd it go?
Oh, sorry. Here, I can pop back up. There you go.
That's okay. I can't copy it.
If you Google terminal bells, it's the first one.
Right.
We're almost there.
We need a holiday themed parody of Jingle Bells about terminal bells. There's plenty of time. There's 10 months to write it. Come on, get the
right.
Yeah. Jason, are you using Rust in your day-to-day?
No. That's I think I've also been seeing the interest about Rust, and it seems like it has a lot of good traits that I'm interested to learn about. But I have I write Go for pretty much everything day to day. And there's no real, I've tried to write Rust. I've tried to write little toy programs in Rust, but if you're not doing it for something, it's really hard to make yourself do it. So that was another one of my sort of goals with this learning experience was let's actually try to make myself learn Rust with this. That I'm sure that you could make Go run on these things too. There's Tiny Go, there's other things like that. But this seemed like an opportunity to also make myself learn Rust if I get there.
But then you're missing the opportunity to master C.
Yes.
This is a feature.
That was the point. Yes. C is fine. I have, I would rather learn Rust than C, but that's my own shortcoming, my own failing.
The speaking of kind of like running different languages on in firmware, announcement, I guess. The all 4 of our submissions to Embedded Open Source Summit were accepted for talks. So go Goliath. But my like background thread project is WebAssembly stuff on microcontrollers, and the Bytecode Alliance has a WebAssembly micro runtime that integrates with Zephyr, and it's really interesting because you can write, like JavaScript or whatever you want and compile it to WebAssembly, and then it just runs it in a little sandbox on the device, which obviously limits the capabilities. But if you look at the I know was it WASI 0.2 just had its big release, which there's a lot of news about. One of the things, or there's multiple of them, proposals is for things like communication interfaces, so like SPI and I2C and that sort of thing, making those available in WASI, which would be really interesting from a running WebAssembly on microcontrollers perspective.
So let's say someone on this call didn't really understand WebAssembly. What would you tell them?
Which one of us is it?
Yeah. I would tell them that WebAssembly is like running machine code in a virtual machine.
Okay, so it doesn't actually go onto the controller. I thought you could like transcode into a binary for the controller.
So you can. I mean, I guess it's a binary either way, whether you're interpreting or executing it natively. WebAssembly micro runtime does have the capability to run it as native code. So it's actually pretty interesting how it does that. So WebAssembly is an instruction set. Also, I think you want yes here.
Okay. I was just about to say thank you.
Yeah. And yeah.
Mm-hmm.
The way it does the like executing native code. So like by default, you compile to WebAssembly, right? So it's WebAssembly machine code with the WebAssembly spec, but it has the ability to execute native code. And the way you do that is you compile it for whatever target architecture you have. So let's say we're using like a RISC-V microcontroller. So you compile to RISC-V machine code, just like you were, building firmware for that device. And then it basically like shoves it into a WebAssembly module, which is like, you can think of it like an ELF file or something like that. And it puts it in like extensions, essentially part of it. It just like shoves all of the machine code in there. And then the runtime knows how to like check and see if it has native code. And if so, it's like, oh, I'll just execute this natively, which you can obviously get some performance benefits with.
So the benefit of that would be that you could more easily write JavaScript and compile it down to something that runs JavaScript and or Python or Rust or Go or anything that compiles to WASM. You can then put on devices. That sounds cool if it works. I hope that works someday. And
debugging might be a little rough.
So the part that I feel like would be it is mostly a like getting started tool right now, I would say. The thing that I think would be a really interesting use case for us, which is kind of like what the background thread is for, is if we had a ton of, you might have seen there, the other option was using a precompiled binary. So for some devices, we just have like a binary already ready to go and you don't have to build anything or install any tools. You just flash to the device. So if we had a binary that had the WebAssembly micro runtime baked into it and also had basically imported functions that allowed you to call the Golioth SDK into the WebAssembly module memory space, then you could have a precompiled binary and flash it on there. And then OTA, which is one of the capabilities of our platform, which I'm not sure we'll get to today, but and just OTA WebAssembly modules down there. And so you can change the functionality of the device without ever having to like get any compilers or anything like that, because you could compile the JavaScript, for example, in the browser and OTA it down there, which would be pretty neat. Wow. Yeah,
that would be pretty cool.
I'm wondering if we skipped a command or two just above the installing the Zephyr SDK toolchain. If you look above that, step 2 and 3 are a
Oh.
West Zephyr export and a pip
Yes.
install command.
Yes. You are totally right.
They'll be quick though, don't worry.
Okay. Thank you. You are eagle-eyed.
The compiler would have told you that you missed something, but it wouldn't tell you what.
Yeah.
The compiler is infallible, and so is Mike.
But otherwise, once this completes, I think we're ready to build something.
And I have done West Blob's fetch, and
Yep.
and I'm about to build firmware after this is done. Then.
Yeah, I think we should just go straight to building Golioth firmware.
Absolutely.
So the Golioth stuff is in a folder called modules lib Golioth firmware SDK.
Okay. Should I not do this one then?
We
Sorry. Oh, I just.
Yeah, you could just skip this one. This one's just going to build like a hello world, not targeting any real device to make sure that you can build. But I'm pretty sure you're going to be able to build. I will probably eat my words, but
challenge accepted.
Yeah, if you are a VS Code sort of person or whatever editor you like, you can probably open that up and open this tree up, and we can use the terminal within that for the build part of it.
Okay.
Aren't you a Vim with no extensions person?
Who, me?
Yeah, did I make that up?
I was, for many years, I was at Google and I used Vim, and they had a fantastic curated like Vim setup that was just incredible.
Yeah.
And then I foolishly left Google without copying any of that. And so for 2 years, I wandered in the woods as a Vim user with no help, with nothing. And I made it work, and then gave up and just used VS Code instead. That's my editor arc. Is I was the genie with all the power, and then I lost all of the help from the extensions. So.
I feel like at one point we were working on something together, and you were writing Go and Vim, but you didn't have like auto formatting or something, which is like, for anyone who writes Go, is kind of like a crime, because Go requires, like, there is one correct way to format in Go. And so I remember seeing that and just being like, oh wow, this is I had to avert my eyes, to be honest.
And I did it without syntax highlighting, and I did it without, that was my lowest point.
Right. I feel like that. Good. Yeah. I mean, I feel like I'm pretty, I don't have like a super complex config or anything like that, but I do have syntax highlighting. And whenever people are like you shouldn't need syntax highlighting, I'm like, why? I don't understand. It's not like it's not, I could get an argument that a lot of the IDE capabilities are something you may not need. But like syntax highlighting is just like literally helping your brain do connecting faster. So I'm like, I don't understand why.
You don't need a window in your office either, but it's really nice to have it if you're going to stare at that wall all day, to stare at the outside instead.
The same people go and buy a hammer and then like meticulously strip off all the padding on the handle. They're like, the only way to use hammers is to have a hard metal piece in your hand. That's it. It's the only thing.
That's funny.
So what are we doing in here?
We're going to go in modules, lib, Golioth firmware SDK, examples, Zephyr, and then hello. I think hello. And I would open the README on this first, because it's going to talk about the credentials that you need to use. And so I would copy those 2 lines, like all of them, because you could just replace them later, and put those into the prj.conf file that's in the same folder.
Okay.
And then let's go back to the README and grab the Wi-Fi ones as well. Should be, you might search Wi-Fi and it'll pop to that area. There you go, down about 5 lines. Yep, right there. And we can take you off screen while you fill in those Wi-Fi.
Oh yeah.
So
Good
that
call.
you're not giving everyone your credentials.
1, 2, 3, 4, 5.
Right. Oh, right. It's my
make sure-
password plus a digit. I forgot.
Make sure to pipe whatever you put in there to say. Just so you
And then Wi-Fi SSID is like my current home Wi-Fi. Okay. 1,
Yeah.
2, 3, 4, 5.
And then the Golioth PSK ID and PSK are what we were working with previously in the web console of Golioth.
Okay, I have those in. I'm ready.
And then if
I'm
you want
ready
to save
for-
and close that file, we'll put
Yeah.
your screen, we'll put your editor back as let us know when you're ready.
Set, ready.
Okay, cool. So that is the configuration. There are several ways to do this, and the README file talks about that. And the last is the build command. And I would use that build command. Technically, that is not your exact board, but I do not believe anything is going to be different in this application. And the reason I don't have it do your exact board is that we have board configuration files that are named to match what is right here. And we'd need to copy those for your board and change the name. And it's just like, why do that if it's kind of the same end spot?
Okay. Are there this is possibly also hidden in the documentation I haven't read yet. Are there like recommended boards? If I was even earlier in this journey and I was like, I want to learn Golioth and Zephyr, and I don't own any hardware, is there like an even more preferred board you would recommend, officially or unofficially, as somebody getting started?
This is a really good board. This is one of the boards that we test in our continuous integration. And if you open that boards directory that is in this sample, you can see the names of them.
Boards, okay.
So there's the ESP32. You have the W room instead of the W rover, but it is very similar. Zephyr supports the W room as well. It's just those files would have to be renamed to match it, and like why go through that right now?
Okay, but there's no effective actual difference in the build process or the code or anything
for what we're using here. Like it could be that you get to some peripheral built into the chip that's different, or I don't actually know the differences. Do you, Dan?
Mike, there might be a difference here because I believe the dev kit C is RISC-V, and I assume that I think the room is ARM, right?
The ESP32C3 is, but these are the ESP32 _ W room or W rover, and those are both like the original ESP32. Gotcha. There's some difference in the modules. Like your module will have stamped on the top of that metal plate W room or W rover. But I do not believe there's anything in this particular build. I guess we'll find out. It'll either work or it won't.
Okay. I love that. So it'll either work or it won't.
Yeah. So we do
want to
very quickly go up a few directories into module lib Golioth SDK.
Oh, yeah. Right. Golioth. For more SDK examples. Oh, here we go.
Yeah. And then perfect. Is it building? I think it might be building.
It's doing stuff.
So here is lesson number 1 on Zephyr. Like very closely watch for warnings here, because it will decide that the kconfig symbols that you have set up aren't quite right, and it will not include the library in your build. And the only way you'll notice is if you like read that warning message, and it'll not be a different color either.
Okay.
But so far it looks like no warnings, so we're happy.
Also, Jonathan just jumped in with a comment that pronouncing these is a kind of like a meme, I think, in our company, probably everywhere. But the difference between prefix both these words with W, rover and room, is usually flash and RAM differences, is what Jonathan says here. But the ESP naming scheme actually, you could probably just say that for all microcontrollers. Microcontroller naming schemes are very upsetting, including was it NXP who recently had the new, they had some like A series. I think they announced a new A series of microcontrollers. But their other series was, I think, M, right? And it was using the ARM M chips. And the A series is not using the A chip. It's just very frustrating. Like, I mean, which you wouldn't really expect them to be using A series chips, but still, it was frustrating.
The board naming department is very different from the marketing department and like good coming up with good names,
right,
folks. So this seems to have worked. I don't see any warnings.
Great build. So we're ready to just do West Flash, and that should, through the power of abstraction, Dan, that should call the tool to Flash.
Through the power of abstraction, you should have no idea what's happening here.
Boy, do I have good news for you.
Yeah,
I absolutely don't know what's happening right now.
And the ESP ones, do they support West Monitor?
Yes. So now you want it. It's actually West space expressive space monitor, and that will reset the chip and do a serial terminal into it. And let's pay attention to what it says for getting out of the serial terminal, because I can never remember. Does it have the command? Is it control close bracket or control T or something? Yeah, control close bracket. So we'll need that later. But if you scroll down now, it should say trying to connect to your router.
This is the name of my Wi-Fi router.
Yeah, I think it does not like something. So possibly.
Let me make sure that I did not foolishly misspell my own.
Okay.
Let those of us who have not misspelled their own Wi-Fi password cast the first stone here.
Yeah.
I have some variable number of repeated symbols in my password. It's very common for me to leave one out or add one in when I'm typing it.
Is that the final number? Is it repeated? 1, 2, 3, 4, 5, 5? Is that what it is?
No, it's somewhere in the middle, but that's all I'll tell you.
Oh, okay. I did have a weird sensation recently where I had a password situation where I was unable to use my password manager for reasons anyway to manage it. And the password I came up with, I was so proud of. And then a little bit later, I was really disappointed because I realized I couldn't tell anyone about it. Okay. And so then I changed the password so that I could tell Katie about it because I was so excited about this password idea. So I changed it to something else so that
you can tell us. We won't tell anybody.
Right. No one else listening to this.
Yeah.
Actually, no, there are 3 people listening to this, and they are very, very malicious.
All right. So I have a question. I had misspelled my password.
All right.
Great. That's the easiest thing to solve.
I fixed it in the config file.
Great.
Do I need to rebuild to be able to have it? Okay.
Yeah.
Great. Okay.
So
that explains why this still.
Yeah.
There are one of the really cool things about Zephyr, and I don't think we'll do it today, is like many of the different drivers and modules that it offers allows you to do interesting things like set values like this while the device is running, so you can get like a shell into it and set credentials, which is pretty neat.
Yeah.
And that's actually built into this example. It was another option in the README that you can play with at some point. This is the pain of working with microcontrollers, waiting for them to flash.
I mean, again, who among us hasn't stared at a container push that takes 5.5 minutes for some reason? So this is not even the hardest place to be right now.
This looks better.
It's
negotiating at least.
It's not disconnecting.
Where's the Wi-Fi password stored? So in this case, we are using hard-coded credentials, so it's being stored in the firmware itself. We have in the READMEs for the Golioth firmware SDK, we have instructions on how to use runtime passwords, and those are stored in a storage partition so that they're persistent across firmware updates.
And if you want to jump over to the console now, Jason, obviously we're able to connect and it's doing some stuff. We can take a look at what it's doing.
60 minutes on the money.
Oh, that is perfect.
Just like we planned it. Where do I see?
Oh, wait, we lost your screen again.
Oh, for real?
Oh, there we go. It's
Yep. If you click the circle under status down below there, there's a refresh button just to the right there. Online a minute ago. And then under logs, we should be getting logs that say hello in them.
Hey.
And there is also an auto refresh button on the upper right that opens a WebSocket into that if you want to see what's coming in live instead of manually refreshing. Up in the upper right, there's an auto refresh. Yeah, and you can choose real time. And then as they come in, we'll see them appear here. Ooh, fancy.
Nice. Counting
you have now mastered embedded.
I did it.
Put it on your CV.
Does the Hello have any RPCs? Or it has the loop delay setting, doesn't it?
No, that would be the setting. So we do each of these granular. However, there is a plan to put in place the kind of kitchen sink, possibly based on the reference design templates that we use, that it's every service all in one. There is something called Golioth Basics, which is going to be updated. So I usually don't start with that one, but that does show more of the SDK in one place.
Okay, so this is broadcasting, like counting, sending it over Wi-Fi to Golioth, authenticating that connection with the PSK secrets, and coming in here. I'm gonna look through the code for this. Like, I realized that I just committed the cardinal sin of just blindly running whatever code you told me to run.
This actually just directly forwards your Wi-Fi credentials to me and Mike. So
and credit cards and bacon. No.
Yeah, right.
I told you it was 1, 2, 3, 4, 5. You didn't have to.
Yeah, I think you'll be surprised about the code. That's what's kind of amazing about the Zephyr situation is Golioth just sits as a module on top of Zephyr, and so there's not a ton of code in here. So you should see there's a callback there that happens when it connects, and that'll tell you like, hey, you're connected. Going down into main, there are some helper functions that are in our kind of like common library, like the net connect. And that's because we're supporting, in this sample, we're supporting Wi-Fi, Ethernet, and cellular. And so we have like kind of one helper function that figures out, do I need those? Do I need to do DHCP? Like, what do I need to get my network standing up?
Based on what variable, based on what like config I have set, if I wanted to disconnect this from my Wi-Fi but use LTE instead or something, is there just like a single config line that I change and NetConnect does the rest?
Yeah, so it's actually based on those files in that boards directory. So if you just want to open up like the two files there, so that is right there, that tells you that, oh, I want to use Wi-Fi. So the status okay means it's turned on. Otherwise, status disabled would be what turns it off. But this is saying, okay, turn on Wi-Fi. And in Zephyr, there's actually a board definition for ESP DevKit C W Rover. That's what we're building for. That sits on top of another definition for the system on a chip, the SoC, for the ESP32 itself. And so we're kind of like building on these like pre-configured settings that are in the open source Zephyr tree. If you want to switch to a different board, then each of those boards is going to have their own thing enabled. So like the NRF 9160 board to the left there is a cellular board.
NRF 9160, yeah.
And you can see like there's a ton of stuff in there that is like specific to that board. In the actual like app level stuff, that's what the prj.conf file is. So that's turning on libraries for just this. Any board that uses this is going to need whatever's in those libraries.
Okay, so by the sort of power of abstraction, I can change boards to at least one of these boards and potentially many, many others. And Zephyr and Golioth will just work. And I can switch even on this board from I guess it doesn't have non-Wi-Fi connectivity, but if it did, I could switch it to LTE mode and it would work over that also. That's so cool.
Yeah, one of my favorites we don't use it too much because it's not necessarily, well, I guess, I don't know, it might be a configuration you would use, but we have one example here. One of our coworkers at Golioth maintains this driver in Zephyr that allows you to use an ESP32 as like a Wi-Fi bridge for one of the Nordic boards. So that's actually in the, I think might be in the README for this one. It's definitely in the README
in this
for
one,
another. Yeah.
Mm-hmm.
Which is like pretty neat. I might have it set up around here.
Yeah, that right there. So it shows you like what pins to connect to the Nordic board from the ESP32 board, and you put a precompiled binary from Espressif onto the ESP32 that turns it into an AT modem.
Let's see if the camera, there you go. So you can see I have my ESP32 over here and my Nordic board over here. And so I can use the ESP32 to basically use this on my Wi-Fi here, which is pretty neat.
Yeah.
And really, any board that runs Zephyr should be able to function this way. You just have to configure the pins that you're connecting and, like the plumbing part of it. But once you get the plumbing done, the C code just kind of runs on everything, which is really nice.
Yeah, nice. Okay, my head is spinning. Where do I go next? I finally got a thing to work. Is the what's the next step if I have like a peripheral I want to add to this board and not just emit hello every second, but like emit the current time or the temperature or the GPS location or something like that? What's that? I suppose there's probably something in the docs, but like what's the next? What do I do next once I get this working?
Yeah, so Micah, you've built some full systems. You can probably speak to this really well, but I mean, typically if you have a peripheral, you need to decide how you're going to communicate with it, and there might be you might have a microcontroller and a sensor that there's already really good support for. Typically, if I have a board that I want to add some capability to, I look at Zephyr and say, okay, what does Zephyr support in terms of like, let's say displays. That's always a fun one to add. What does Zephyr support there? And, make sure it's going to be compatible. And then usually you can leverage the drivers that Zephyr offers to make that a really seamless experience. But Mike, you've worked on some of our reference designs, which are more fully fledged systems. What's that been like for you?
Yeah, I mean, the first thing I would do, Jason, is just go over like the rest of the examples that are in Zephyrs, because there's, sending sensor data, like it'll simulate sensor or temperature data that it's sending to LightDB stream, or sending an RPC, which is where you type something into the Golioth console and it sends it to the device processes it, and then sends you the output, which is super cool. And then those you can just start, like most things I start from the Hello app and then I add other services and other things to it. When it comes to actually adding on a sensor, I will almost always start at something called the Zephyr bindings index. If you want to like Google that and bring that up, it is kind of like the master calendar of all the things that are currently supported within Zephyr. And it is always going to be the happy path for adding sensors, because you don't really need to do anything other than work with this sensor abstraction layer. If you search on this page for like BME 280, so that shows you like, here's a device that you can connect it either to the I2C bus or to the SPI bus. And basically in those configuration files, remember where we had like the Wi-Fi node that said status okay? You would like add a node on either your I2C bus or your SPI bus that has a block for that particular code. And then Zephyr automatically figures out how to build in a driver for that. And then it opens up the sensor API for you to use. The sensor API is things like you have to initialize it. So it's got an initialization thing where you just call the initialization and it knows what to do for that device. And then there's like a fetch, which just says, go read every possible setting from this, and it returns a struct. And then you can just read out whatever values are in that struct. A greatly simplified version. I think you might be muted, Jason.
Typical Jason. So this is like the list, the menu of stuff that is Zephyr. It is on Zephyr easy mode, basically. Like I don't have to write. I get to write on top of the Zephyr abstraction if I use one of these things.
Yeah, that's right.
Okay.
And then if you want to go back to your VS Code again,
yeah,
I always like to point out that there are a whole bunch of samples in Zephyr as well. So go back down to like the root folder on the Explorer on the left there, like the workspace folder.
Okay.
And then go into Zephyr and go into samples. And you can see like there's probably a sensor. Yeah, there's a sensor subdirectory, and I bet there's a BME280 directory. And you can see it's a very similar structure. So it says a prj.conf file. It has a boards directory with some board examples. Like you can just kind of crib all of the stuff that you need off of examples like this. So here's that node, the BME280 node, and it's I can't quite read. It's a little small, but is that SPI? Or
oh my. Yeah.
Yeah, so it's saying for whatever chip this is, this is for the Raspberry Pi Pico, use SPI bus 0 and add this node to it. So this tells Zephyr, like, I have this device connected on this bus. And like if it's I2C, there's addresses for devices. So your address would be specified here. Like all of that stuff is specified here. And then if you go into the C file for this one,
into source main.
Yep, yeah. There you go. Then all of the like abstraction stuff is in here, so that you can see there's a like finding the device and setting it as some pointer probably to that device, and then there's the sensor abstraction, so the actual sensor fetch, and then getting each of those channels, which are like predefined. And I think one of the coolest things with Zephyr is they have an interactive shell over the serial terminal, and you can turn on the sensor shell and actually like live interact with whatever's connected to the device without having to write any C code, just because it uses this sensor abstraction layer. So Zephyr already knows like this common language to talk to a sensor that's capable of reading temperature, pressure, and humidity.
Yeah. So this just to repeat what you said to make sure it sticks in my smooth brain. This is an example that connects to this BME280 device, which is some sort of sensor. And if I ran this with a BME280 device connected, it would detect that device, be able to communicate with it, be able to understand both, have it understand that language. And then every second it would print out the current temperature and pressure and humidity. If I wanted to have that, like the mashup there, then is like my sensor is harvesting this information and the board and sending it to the board, and the board could also connect to Wi-Fi or LTE or something, and then communicate it back up to Golioth to track it. And awesome.
Yeah, if you want to check out some of those reference designs I mentioned before, for example, this air quality one, it's going to show an example of doing something very similar to that, where you're talking to a peripheral and then forwarding that along to the cloud. So that one might be a good one to take a peek at.
Awesome. Yeah. I feel like the with my even basic knowledge, it seems like once I understand all the Legos, once I can put the Legos together, there are a million Legos to put together. There's
right.
sensors for stuff and connectors, and emitters for data or whatever. Like I'm excited to get to that juncture point where it's like, all right, now off to the races. Anything you can make, you can make.
Yeah, and to your question on mashing that up, it's the basically one change in that example file where it was doing the print K, which is Zephyr's kernel version of printf.
Mm-hmm.
You could change that to a Golioth stream set command, and that would just take what you would have printed out and push it up to the Golioth cloud. So we try to make it very simple to drop in those services. So you basically don't need to know much of what's going on in the background.
Yeah, awesome. Well, I am required to ask what happens when the abstraction breaks down. What, like, the abstraction, sitting on top of the pile of abstraction seems clearly way better than me mucking with Rust tool chains to no effect. But what will happen when some board I have isn't supported, or if there's a bug in the abstraction that means, you know, numbers more than 3 can't be broadcast or whatever that. What's the what do I do when things fall apart besides come on stream again and bug you with my questions, which I will do.
Well, we have a forum, so we would love you to bug
Excellent.
us with your questions on the forum. And I always say, if you're thinking about it or having a problem with it, so is someone else. So you're helping, you know, it's a multiplier to have us discuss openly. And I feel like our staff is very responsive on the forums to that. The other thing is these are open source projects. So our SDK, device SDK that's sitting on top of Zephyr is open, and the Zephyr tree is open. So you can go and look and be like, why is this performing the way it's performing? And I think the place where it breaks down is I've told you, go look at this index and see what's already in Zephyr. And now I have a customer or some project needed. It's got this sensor and it's not in Zephyr. So like, that can be a very big hill to climb depending on what kind of support you have. So if the device manufacturer already makes available some kind of driver that's in C, that will be pretty easy to use, because basically you can always go down to the register level, but the device connects somehow to that microcontroller, probably on like an I2C or an SPI bus. Those buses can be directly addressed with like read-write stuff. So if you just know, like, here's my driver in C, I just need to write a little abstraction so that when my driver tries to write to a bus, it actually calls the right function in Zephyr. And once you've got that stitched together, and it works pretty well. And we've gone this path many times with our designs, is like, we'll add something like this, we'll get it working, and then we'll decide, okay, we should actually make this into a driver module so it uses the abstraction layer and we're not calling things directly. And then we'll do the extra work for that. But I do think it's incremental. So like, you just kind of get it working and you're like, that's good enough. Let's see how much I use this and need it. And then another sprint, I'll work on turning that into a proper Zephyr driver.
Yeah. That story arc sounds very familiar to me. Like, get it to work. It's crap code. I hope no one ever sees this. And then it works. Do a demo, and then like, okay, now I'm going to refactor for like something I feel comfortable showing another human. So
I mean, we had a reference design where like the 16-bit version of the part was supported in Zephyr, but the 8-bit wasn't, or vice versa or something. So we couldn't quite use the abstraction layer. But when you looked at the data sheet for it, it was like a shift register. So it's basically just like twiddling a couple of pins. And so it's much easier to just say, do I need to add this to a driver, or can I just like drive the pins that I need and read what's coming out?
Okay. I almost understood that.
I think complexity is king, right? So we've had a situation where we had a time of flight like laser distance sensor that had like incredibly complicated math and valuing and stuff, and like the driver for that was not going to be something we could port. But if you get something where it's like literally, you could write a driver on a sheet of paper, like it's trivial to make that work. Yeah,
that's cool. Well, I feel like I've achieved something today. I made this little thing connect to the internet and tell me, it can count to 18 or whatever. So I feel accomplished.
I'm very happy, because I was telling Mike before we came on that I feel like I have been very flaky on our goals of streaming. So I just did what everyone did and just made it my work. So, it worked out here. But two things actually, I think it would be cool. No pressure, right? Whenever you have time or whatever. But in the future, if you keep going and build something, or you find something around the house that you want to automate or something like that, if you come back and show that off, I think that'd be really cool. And then also, I would love to have you come and join sometime when Mike goes through some of our. We use GitHub Actions for our hardware in the loop runners. I know that you are a Very, very experienced GitHub Actions user. But I
Abyss
think
domain expert is the
Yeah,
Abyss
right.
domain expert is the title.
Right,
No.
right. But I think there might be some interesting bits that you've never played with there. So
Yeah.
it might be, and I'm certain that we would learn some stuff from you. So I think that would be a cool one to have you back on as well.
Yeah, absolutely. I'm more than happy to. I feel like that would be fun. I'm excited. I'm always excited to see what people are doing, what terrible creations they've done with GitHub Actions. Haven't made quite a few myself. So
Right.
but yeah, thanks guys. This has been super fun.
Yeah, I thought it was a ton of fun. Thanks for coming on and working through it.
Cool.
All right, now to go make stuff blink, and then next world domination.
Right, right. All right. Well, have a good weekend, folks, and I'll definitely talk to you next week, Mike, but I'll probably talk to you as well, Jason. So have a good weekend.
All right. See you.
Yeah.